question number 12. It was there in question number 12 AP, the third exercise. If show that A1, A2 and A3 from an AP where AN is defined as 3 plus 4n. Also find the sum of first 15 terms. So AN is equal to 3 plus 4n is given, AN. So in the place of AN we have to find A1, A2, A3. So A1, if we take n as 1, then here also we will put the value of 1 because AN value is given. So this is 3 plus 4, 1 to 1, 7. A2, 3 plus 4 into 2, 8 plus 3, 11. A3, 3 plus 4 into 3, 12 plus 3, 15. A4, 3 plus 4 into 4, 19. So in this way the AP will be. So the AP will be the first term 7, 11, 15 and 19. In this way we have to go. Then we got the AP now. So now the first term A is equal to 7 and the difference D is equal to 11 minus 7, that is 4. So we have to find the sum of first 15 terms. So sum of first 15 term, we know the formula n by 2 bracket 2a plus n minus 1 d. So here n is equal to 15, a we know 7, d we know 4. So after calculating we are getting the sum of first 15 terms are 525. Next is question number 15. It was given if Sn denotes the sum of first n terms of an AP, prove that S30 is equal to, we have to prove, we are coming in question number 14. Question number 14, it was there in an AP the sum of first n term is equal to 6n minus n square. So we have to find the 50th term, the 25th term we have to find, not the sum of 25th term. Is 25 we don't need to find, we have to find the 25th term. So a 25th we have to find. But we don't know ki AN is equal to what. In the previous sum it was given AN is equal to this. So we have to find the AN term. Okay, the n term we have to find. So Sn is given this. So Sn, sum of n term is given. So sum of n minus 1 term we will see in the previous one. Okay, suppose this is 25th. Suppose this is 25th, 24, whatever the term. The previous term we have to find. Okay, then we can get the minus thing. So you see, so if n term is this, so n minus 1, previous one, sum of this term is this, n term is this. So sum of n minus 1 means the previous term will be n minus 1. Also here n minus 1 because we have written n minus 1. So 6n minus 6 minus n minus 1, you have to do a minus b whole square, a square minus 2ab plus b square, 6 minus n square minus minus plus 2n plus minus minus n. So 6n plus 2n is equal to 8n, minus n square minus 6 minus 1 minus 7. So we got is n minus 1, the sum of n minus 1 term is this, sum of n term is this. So we can find the difference, that is AN is equal to sum of n term, sum of n term of the AP will be Sn minus S minus 1. Okay, so Sn we know the value, S minus 1 also we know the value. So n square is getting cut because there is minus, the sign will get changed here, minus 8n minus minus plus n square minus minus plus 7. So minus n square plus n square cut, 6n minus 8n will be minus 2n plus 7. So we got the thing now, AN is equal to minus 2n plus 7. So now we have to find a 25th term. So instead of n we will write here n 25th 7, and after calculating we are getting minus 43. Now in the 15 one there is a proof. If Sn denotes the sum of S number of an AP, prove that S30 is equal to 3 into bracket S20 minus S10 that we have to find. So it is written Sn denotes the sum of m number. So that is the formula. Sn denotes the sum of m number. This is the formula. So first we have to find the S30 term, S20, S10, because the three things is given in our question. So S30, instead of n we will just write the value of n30 here, and a and d we don't know, we will write it like this. This is equation 1. S20 also, instead of just n we will write the value n, but a and d we don't know, so we will keep it like a and d. So a10 also 10, and we are getting this value. So now it was there, we have to prove S30 is equal to 3 S20 minus S10. So the three sums we have got, S30, S20 and S10, we have separately find their value. So now you see RHS is this, so RHS is this 3 into S20 and S. So S20 value we know from equation 2, we got S10 from equation 3, we got the value, minus sign is there, that's why minus 10a plus minus 45d. Now 20a minus 10a 10a, 190d minus 45d will be 145d. So 3 is outside, we have to multiply the whole thing with 3. It is coming 30a and 3 445d, and you see this is the value of S30. So equation 1 we are getting this is equal to S30 proof. Okay, so this proof we have to do. Now in question number 16 it was there, find the value of first 1000 natural numbers. Once again, find the value of first 1000 positive integers. Positive integers means we all know in this is 0, 1, 2, 3, 4, 5, this one all plus. If we go on that side, all will be minus. So positive integers up to 1000. So there will be one sum of, it was given the sum of first. So in the plus sign we will write 1 plus 2, 3 plus 4 plus 5 dot plus 1000 up to we have to go, because all are the natural numbers positive. So now here a is equal to 1, d is equal to 2 minus 1, 1, and n is equal to how many terms are there? From 1, if we go 1000, it will be 1000 numbers, so n is equal to 1000. So we have to find the sum of first 1000 positive integers. So n is equal to 1000. So instead of n you put 1000. A we know 1 and d also we know 1. So you solve and you will get the answer, this 500. Okay, now in the next question it was there, question number 2, find the sum of first 15 multiples of 8. 15 multiples of 8. 8 multiples, we know 8 ones are 8, 8 twos are 16, 8 twos are 8 threes are 24, 8 fours are 32, 8 fives are 40. In this way we have to go up to 15 multiples. So 15 multiples of 8, 15 into 8, 120, so up to 120. So how many? A is here 10, d is here 16 minus 8, and how many terms? 15 multiples. n is not equal to 120. This is the 15 multiples of 8. So here n is equal to 15. So S15 we have to find, because n is equal to 15. So a and d value to we know, and n value also we know, and you calculate and you got the answer 960. Now question number 17. Find the sum of all 2-digit natural number which are divisible by 4. 2-digit natural number starts from 10. 10 is not divisible by 4. Then 11. 11 is not divisible by 4. Then 12 is divisible by 4. 13 is not divisible by 4. 14 is not divisible by 4. 15 is not divisible by 4. 16 is again divisible by 4. So after 12, 16, what is the gap? 4. So 12, 16, then again 4 gap, 20, 24, 28, 32. In this way we have to go up to 2-digit natural number. So we know 100. is a 3-digit natural number. So before 100 we know 99 is not divisible by 4, 98 is not divisible by 4, 97 is not divisible by 4, but 96, you see, 4 2s are 8, 1 6, 4 4s are 16. So 96 is divisible by 4. So this is the last one, last 2-digit number which is divisible by 4. Okay, so this is the AP we got. Now A is equal to 12, B is equal to 4, but N, how many terms are there? You know? No, you don't know. But in the previous one we know it was given first 15 multiples of 8. That's why we know that is the N means here 15. But here how many numbers are there? How many numbers are total terms are there? We don't know. So we have to find the N here. So N we don't know. A we know 12. D we know 16 minus 12 4. But we don't know N. So there is a formula, last term is equal to A plus N minus 1 D. So the last term is 96. A is equal to 12, N minus 1 D. You know that D also here. From here you got N is equal to, we are getting N is equal to 22. So now we got the total terms are 22. So sum of 22 terms we have to find, because A also we know, D also we know, and the answer is coming 1188. Clear? Next question it was there. Next question was, find the sum of all natural numbers between 100 to 200 which are divisible by 4. Between 100 to 200. So hundreds is also divisible by 4, but we will not take, because that is written between 100 to 200. Okay, so we will not take 100 and 200. Between 100 and 200 which numbers are divisible? You see, 101 is 1 with, in what is the rule of divisibility of 4? In last 2 digits, the number which will be present, which must be divisible by 4. Okay, that is the thing. Last 2 digit में जो number present है वो 4 से divide होना चाहिए. So 101 is not divisible, 01 is not divisible by 4. 102, 02 is not divisible by 4. 103 is not divisible by 104. Yes, 4 is divisible by 4. So the first number will be 104. Next you see 105 is not divisible, because in 4th table 5 is not coming. 106 in 6th table, in 4th table 6 is also not come. 107 in 4th table 7 also not come. 108, yes, in 4th table 8 comes. So after 104 it is 108. So what is the difference? 4. So in 4 difference we have to go 104, 108, 112, 116, 112, 120 in dot dot dot. Before 200 we have to stop. So before 200, so we know 200, so we will not calculate because it was there ki between 100 and 200 we have to find. So 199, 99 is not come, 9 is not come, 9 doesn't come in 4th table. Then 198, you see 8 to come. So you see the division for 4 is 16, 4 4 is 16, 3 8, 38, 4 9s are 36. So 198 is also not divisible. 197, 97 will not, 7 will not come. So 196, you see 96 is divisible by 4 or not? Or is a 16, 3 6 4 9. Yes, 196 is the last number which is divisible by 4. So here also we don't know the N. How many terms are there? We don't know. So that's why but we know A is equal to 104, D is equal to 108 minus 104. That is difference is we are getting 4. But we know the last term, that is 196. So last term is equal to A plus N minus 1D. In the last term 196 we put the value. A is equal to 104, D is equal to 4, and we find that N is equal to 24. Then the sum of N terms we have to find, that is coming 3600. Clear? In the next sum it was there, find the sum of all multiples of 9 between 300 to 700. Between 300 to 700 all multiples of 9 we have to find. Between, okay, between. Acha, so 301. So what is the rule of multiplication? The number must be divided by 3 and 9. Okay, this is the rule of multiplication. Any number divided by 9, if we have to check, then the number must be divisible by 3 and 9 both. Acha. So first 301, it is not divisible by 3 also, because 301, 3 plus 0 plus 1, it is getting 3 plus 0 plus 1, it will get 4. 302, 3 plus 0 plus 2, it is coming 5. 5 also not come in 3's table. 303, 3 plus 0 plus 3, 6. So 6 comes in 3's table, but you check 3, 9 is, it is divisible by 9 or not. 3, so it is not divisible by 9. Okay, 9 it is not divisible by 9. So 905, 3 plus 0 plus 8, it is, sorry, 3 plus 0 plus 5 is coming 8. 906, 306, this plus 0 plus 6, so it is coming 9. So now check 306 is divisible by 9 or not. Yes, it is divisible. So the first number we got 306. Acha, by 9 we have to divide, right? So after 306 you count plus 9. If you add 9 with this, we will get 315. That will be the second number which will divisible by 9. After 315, you add this number with 9, you will get 324, which is again divisible by 9. 324, you add 9 with this number, you will get the next one 333, which is again divisible by 9. So in this way up to 700 we go. So before 700, the number which will be divisible by 9, it will be 693. You have to calculate that one. Okay, acha. So here we are getting same thing. A is equal to this, D is equal to, we know the difference 9. The last term we know, that is 693. This is the last term. From here we will put the value of A and D, and the last term is 693, and you will get, you find the value of n. From n, then Sn you have to find. Clear? And the last question is very easy, that is find the sum of all natural numbers less than 100 which are divisible by 6. Less than 100 which are divisible by 6 means 6 table we have to write. 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 50, 30, 6 6s are 36. In this way, before 100 we have to stop. So before 100, the number which will be divisible by 6, it will come 96. Okay, 96. So we got the first term A, we got the difference D is equal to 12 minus 6, 6, and L. From this formula we have to find the AN. So L we know 96, A we know 12, D we know 6. So from here we have to find N, and after that we have to find Sn. Okay, so in this way this chapter ends here, and you solve the last two sums and find the answer.